From Data to Transcendence, Understanding Information, Knowledge, Wisdom, and Beyond. Creating a comprehensive course covering such vast and abstract topics requires a structured approach. To effectively teach concepts spanning from data to the highest forms of wisdom and science, we'll need to design a curriculum that gradually builds understanding, encourages critical thinking, and fosters insights beyond conventional knowledge boundaries. Let's outline a multi-module course that can be tailored to different learning environments, whether it be self-study, a university course, or an online learning platform. Course title: From Data to Transcendence, Understanding Information, Knowledge, Wisdom, and Beyond. Module 1, Foundations of Data. Objective: introduce the concept of data, its types, collection methods, and basic processing techniques. Topics: What is data? Types of data, data collection methods, basic data processing. Module 2, Information Theory. Objective: explore how data is transformed into information and how information is quantified and communicated. Topics: Data versus information, information theory basics, encoding and decoding information, information systems. Module 3, The Path to Knowledge. Objective: understand how information is analyzed and synthesized to form knowledge. Topics: information analysis, knowledge creation processes, organizing and structuring knowledge, knowledge management systems. Module 4, Wisdom and its application. Objective: delve into the concept of wisdom, its distinction from knowledge, and its application in real-world decision-making. Topics: knowledge versus wisdom, characteristics of wisdom, wisdom in leadership and ethics, applying wisdom in diverse fields. Module 5, Beyond Wisdom, the Pinnacle of Understanding. Objective: examine the limits of wisdom and explore concepts that transcend traditional wisdom, including spiritual and philosophical dimensions. Topics: limits of conventional wisdom, philosophical perspectives on wisdom, spiritual wisdom, transcendental wisdom and understanding. Module 6, The Science of Everything. Objective: connect the dots between knowledge and science, exploring the scientific method as a tool for acquiring knowledge and understanding. Topics: science as a form of knowledge, the scientific method, major scientific revolutions, the future of science. Module 7, Synthesis and Beyond. Objective: integrate concepts from previous modules to explore the highest forms of knowledge, wisdom, and understanding possible. Topics: integrating data, information, knowledge, and wisdom, envisioning beyond current limits of understanding, the role of imagination and creativity, the ultimate quest for understanding. Course activities: interactive lectures, to introduce and explain complex concepts. Discussion forums, for students to debate and reflect on course material. Case studies, real-world applications of wisdom and knowledge. Research projects, encourage original thinking and exploration beyond the curriculum. Final project. Students will conceptualize and outline a novel idea, theory, or model that represents a form of understanding, wisdom, or science that transcends current human capabilities, supported by research and imagination. This course framework is a starting point. It would require further development, including specific lesson plans, learning outcomes, and assessment methods, to ensure it provides a comprehensive exploration of these profound topics. Creating 2 comprehensive, verbatim lessons for Module 1, Foundations of Data will provide a structured approach for delivering the module's objectives and topics. Each lesson includes an objective, key points, and a detailed script for teaching. Lesson 1. What is data? Objective: introduce students to the concept of data and its fundamental role in analysis and decision-making. Materials needed: PowerPoint slides, examples of different types of data, charts, tables, images, and a worksheet for a class activity. Detailed script. 1. Introduction to data. Welcome, everyone. Today, we embark on our journey to understand the world of data. Data surrounds us in every moment of our lives, from the numbers on our watches to the posts on our social media feeds. But what exactly is data? 2. Definition of data. Data are raw facts and figures. They are unprocessed and uninterpreted. Like the ingredients for a recipe, data needs to be processed and analyzed to give us information. Can anyone give an example of raw data from your morning routine? 3. Importance of data. Data is crucial because it forms the foundation of information and knowledge. In every field, data helps us make informed decisions. For example, doctors use patient data to diagnose illnesses, and businesses analyze sales data to understand their market. 4. Activity: identifying data in everyday life. Let's take a moment. Think about your morning today. Identify 3 instances where you encountered data. Share with a partner. After sharing, as we see, data is everywhere, influencing our decisions and perceptions. 5. Conclusion. Understanding data is the first step towards turning raw facts into valuable insights. Keep the examples you thought of in mind as we delve deeper into the types of data in our next lesson. Homework assignment. Collect 5 different pieces of data from your home or online. Write a brief description of each, explaining why it is considered data. Lesson 2. Types of data and collection methods. Objective: dive deeper into the various types of data and explore basic data collection methods. Materials needed: PowerPoint slides, examples of qualitative and quantitative data, and a simple survey for an in-class activity. Detailed script. 1. Types of data. Welcome back. Today, we'll explore the different types of data. Remember, understanding the type of data you're dealing with is crucial for analysis. 2. Qualitative versus quantitative data. Data can be broadly classified into 2 types, qualitative and quantitative. Qualitative data describes qualities or characteristics, such as the color of a car. Quantitative data, on the other hand, deals with numbers, like the car's speed. 3. Structured versus unstructured data. Another way to look at data is whether it is structured or unstructured. Structured data is organized and easily searchable, like a spreadsheet. Unstructured data, such as an email, is not organized in a predefined manner. 4. Data collection methods. Collecting data can be done in many ways, from simple observations to conducting surveys and experiments. The method you choose depends on the type of data you need. 5. Activity: conducting a simple survey. Let's conduct a quick survey. Each of you will ask 3 classmates their favorite movie genre. We're collecting qualitative data here. Afterward, we'll discuss how we might analyze this data. 6. Conclusion. Understanding the types of data and how to collect them sets the stage for our next topic, processing this data into information. The way we collect and categorize data is crucial for the insights we derive from it. Homework assignment. Create a simple survey with at least 5 questions. It can be about any topic of interest. Aim to collect both qualitative and quantitative data. We'll use this survey in our next lesson on data processing. For Module 2, Information Theory, we'll create 2 detailed lessons that build upon the foundational understanding of data from Module 1. These lessons will help students grasp how data becomes information and delve into the basics of information theory, including the processes of encoding and decoding information, and understanding information systems. Lesson 3, Data versus Information. Objective: explain the transformation of data into information and why this process is significant in various contexts. Materials needed: PowerPoint slides, real-world examples of data turning into information, for example, weather data to weather forecast, and a case study for group discussion. Detailed script. 1. Introduction to information. Building on our understanding of data, today we explore how data is transformed into information. While data are raw facts, information is what we obtain when data is processed and contextualized. Let's dive into this transformation process. 2. Understanding data versus information. Imagine you're looking at a spreadsheet full of numbers. Those numbers are data. Now, if we organize this data to show the monthly expenses of a household, we've created information. Information, therefore, is data made useful and meaningful. 3. The significance of transforming data into information. This transformation is crucial because it allows us to make decisions and understand the world around us. From deciding what to wear based on a weather forecast, to a business determining its next move based on sales data analysis. 4. Real-world example, weather forecasting. Let's consider a real-world example, weather forecasting. Meteorologists collect data from various sources, like satellites and weather stations. This data is then processed and interpreted to create a weather forecast, the information that helps us plan our days. 5. Group activity, case study analysis. In groups, analyze the provided case study where raw data was turned into valuable information. Discuss the process and its impact. Present your findings to the class. 6. Conclusion. Understanding how data becomes information is a key step in the journey of knowledge. It's not just about collecting data but about processing it into a form that is meaningful and actionable. Homework assignment. Find an example of raw data online, for example, a dataset on a government website. Write a brief report on how this data could be processed into information, including what tools you might use and the potential value of the information created. Lesson 4, Information Theory Basics. Objective: introduce the basic concepts of information theory, focusing on the processes of encoding and decoding information, and the role of information systems. Materials needed: PowerPoint slides, examples of encoded information, for example, Morse code, binary code, and an interactive encoding activity. Detailed script. 1. Introduction to information theory. Today, we'll explore the basics of information theory, a field that studies how information is measured, transmitted, and processed. This theory is fundamental to understanding modern communication and data processing systems. 2. What is information theory? Information theory deals with the encoding, transmission, and decoding of information. It helps us understand the limits of signal processing and communication, ensuring that data is transmitted efficiently and accurately. 3. Encoding and decoding information. Encoding is the process of converting information into a specific format for transmission or storage, while decoding is the reverse process. For example, computers use binary code to encode and decode data. 4. Example, Morse code. Let's look at Morse code, an early form of encoding. It converts letters and numbers into dots and dashes, allowing for the transmission of messages over long distances without the need for complex technology. 5. Activity, encoding a message. In pairs, encode a simple message using Morse code or binary code. Then, swap with another pair and decode their message. This exercise demonstrates the fundamental concepts of encoding and decoding. 6. Information systems. An information system is a set of components that collect, process, and disseminate data or information. It includes not just technology but also people and processes. These systems are crucial in turning data into actionable information. 7. Conclusion. Information theory provides the groundwork for all modern communication and information processing systems. By understanding the basics of encoding, decoding, and information systems, we can better appreciate how data is transformed and utilized in our digital world. Homework assignment. Choose an everyday digital device or system, for example, a smartphone, the Internet. Write a brief essay on how it uses the concepts of information theory to process and communicate data. These lessons guide students from the transformation of data into information to a deeper understanding of how information is encoded, transmitted, and decoded. By grounding these concepts in real-world examples and interactive activities, students can grasp the practical applications and significance of information theory in various fields. For Module 3, The Path to Knowledge, we'll craft 2 detailed lessons aimed at explaining how information is refined into knowledge. This process involves analysis, synthesis, and effective organization, utilizing both traditional methods and modern knowledge management systems. Lesson 5. Analyzing and synthesizing information into knowledge. Objective: guide students through the processes of analyzing and synthesizing information to create knowledge, highlighting methods for organizing and structuring this knowledge. Materials needed: PowerPoint slides, examples of knowledge synthesis, research papers, analytical reports, and a case study for group work. Detailed script. 1. Introduction to knowledge creation. Welcome, scholars. Building on our understanding of data and information, today we delve into how information is analyzed and synthesized to form knowledge. Knowledge isn't just accumulated information, it's information made insightful. 2. The process of analyzing information. Analysis involves breaking down information into its components to understand it better. It's about asking questions, identifying patterns, and discerning relationships. Think of it as dissecting a complex puzzle to see how the pieces fit together. 3. Synthesizing information. Synthesis, on the other hand, involves combining disparate pieces of information to form a coherent, comprehensive understanding. It's where we begin to see the big picture and gain insights. 4. Organizing and structuring knowledge. Once we've synthesized information into knowledge, it must be organized and structured effectively. This could be through categorization, hierarchies, or mapping. Proper organization allows for easier access and application of knowledge. 5. Activity, case study analysis. In groups, analyze the provided case study where information was synthesized into knowledge. Focus on the analysis and synthesis processes. Present your insights and how this knowledge could be organized for practical use. 6. Conclusion. The path from information to knowledge is critical in any field. It's not just about having access to information but about understanding and applying it effectively. This is what transforms data and information into actionable knowledge. Homework assignment. Select a topic of personal interest and gather 5 sources of information on this topic. Analyze and synthesize this information to create a short piece of knowledge, for example, a mini research paper. Reflect on how you organized this knowledge. Lesson 6, Knowledge Management Systems. Objective: explore the role of knowledge management systems in organizing, storing, and sharing knowledge within organizations. Materials needed: PowerPoint slides, examples of knowledge management systems, and a group discussion scenario. Detailed script. 1. Introduction to knowledge management systems. Today, we are focusing on how knowledge, once created, is managed and utilized. Knowledge management systems, KMS, play a pivotal role in this process, enabling the storage, retrieval, and sharing of knowledge. 2. Defining knowledge management systems. A knowledge management system is a technology-based system designed to facilitate the organization and sharing of knowledge within an organization. This includes databases, document management systems, and collaboration tools. 3. The importance of KMS. KMS enhance organizational learning, decision-making, and efficiency. They ensure that valuable knowledge is not siloed or lost but is accessible to improve outcomes and foster innovation. 4. Features of effective KMS. Effective KMS feature robust search capabilities, intuitive categorization, and strong security measures. They also promote collaboration and knowledge sharing among users. 5. Activity: designing a KMS. In groups, sketch out a basic design for a knowledge management system for a hypothetical company. Consider what features it would need, how knowledge would be categorized, and how users would interact with it. 6. Conclusion. In our information-rich world, the effective management of knowledge is crucial. KMS provide a framework for harnessing the power of knowledge, making it a key asset for any organization. Homework assignment. Research an example of a knowledge management system used in a real-world organization. Write a brief report on its features, how it's used, and the impact it has had on the organization's operations. These lessons transition students from the theoretical understanding of how knowledge is formed to the practical application and management of knowledge within organizational contexts. By engaging with these concepts through real-world examples and interactive activities, students will gain a deeper appreciation for the importance of effective knowledge creation, organization, and management. For Module 4, Wisdom and its application, we'll craft 2 detailed lessons that focus on understanding wisdom, distinguishing it from knowledge, and exploring its application in various real-world contexts, including leadership, ethics, and various professional fields. Lesson 7, Understanding Wisdom. Objective: introduce the concept of wisdom, highlighting how it differs from knowledge and exploring its key characteristics. Materials needed: PowerPoint slides, inspirational quotes or video clips about wisdom, and case studies illustrating wisdom in action. Detailed script. 1. Introduction to wisdom. Today, we embark on a profound journey from the realm of knowledge to the exploration of wisdom. Wisdom is the judicious application of knowledge for the greatest good. It's knowing when and how to apply what we know. 2. Knowledge versus wisdom. While knowledge is about understanding facts and truths, wisdom goes a step further. It involves judgment, timing, and empathy. For example, knowledge is understanding how a seed grows. Wisdom is knowing when to plant it to yield the best crop. 3. Characteristics of wisdom. Key characteristics of wisdom include deep understanding, empathy, ethical judgment, foresight, and humility. Wisdom is not just about what is right for the individual, but what is best for the community and the environment. 4. Wisdom in historical contexts. Throughout history, wisdom has been revered. Philosophers like Socrates and Confucius centered their teachings around the pursuit of wisdom. In modern times, wisdom is often associated with leadership and moral clarity. 5. Activity, analyzing wisdom. Let's analyze case studies of individuals who have demonstrated wisdom in various fields. Discuss in groups the decisions made, the application of wisdom, and the outcomes. Present your analysis to the class. 6. Conclusion. Wisdom transcends mere knowledge. It involves a deeper understanding of people, things, events, or situations, enabling the ability to choose or act to consistently produce the optimum results with a minimum of time and energy. Homework assignment. Identify a person you consider wise. It could be someone you know personally or a public figure. Write an essay on why you consider them wise, citing specific actions or decisions that demonstrate their wisdom. Lesson 8. Applying wisdom in leadership and ethics. Objective: explore how wisdom is applied in the contexts of leadership and ethics, and its significance in various professional fields. Materials needed: PowerPoint slides, examples of wise leadership and ethical decision-making, and role-play scenarios for class participation. Detailed script. 1. Wisdom in leadership. Leadership demands more than just knowledge, it requires wisdom. Wise leaders make decisions that balance the needs of the individual with those of the community. They lead with empathy, foresight, and integrity. 2. The role of ethics in wisdom. Ethics are fundamental to wisdom. Ethical wisdom involves understanding the broader impact of our actions, making decisions that are just and fair, and considering the well-being of all stakeholders. 3. Examples of wise leadership. Consider leaders who have navigated complex challenges with grace and foresight. For instance, Nelson Mandela's leadership in fostering reconciliation in South Africa showcases wisdom in action. 4. Wisdom across fields. Wisdom is not confined to any one field. It is equally applicable in medicine, where doctors must make tough decisions, in business, where ethical considerations must guide conduct, and in education, where shaping minds demands deep understanding. 5. Activity, role-playing ethical decision-making. In groups, you will role-play scenarios that require wise decision-making. Consider the ethical implications of your decisions and their impact on various stakeholders. Reflect on the wisdom applied in your decision-making process. 6. Conclusion. Applying wisdom in leadership and ethics requires a balance of knowledge, judgment, and empathy. It is about making decisions that not only solve problems but also enhance the well-being of others and promote fairness and justice. Homework assignment. Choose a professional field of interest to you. Research and write about a situation where wisdom significantly impacted decisions or outcomes. Analyze the balance between knowledge and wisdom in this context. These lessons aim to deepen students' understanding of wisdom, its distinction from knowledge, and its crucial application in leadership, ethics, and professional practice. Through exploring wisdom's characteristics and applications, students will learn how to integrate wisdom into their decision-making processes, contributing to more ethical, empathetic, and effective leadership in any field they choose to enter. For Module 5, Beyond Wisdom, the pinnacle of understanding, we'll develop 2 lessons that push the boundaries of conventional wisdom to explore deeper, transcendent understandings. This module will invite students to consider wisdom from philosophical and spiritual perspectives and to ponder the nature of transcendental wisdom. Lesson 9: Exploring the limits of conventional wisdom. Objective: discuss the limitations of conventional wisdom and introduce philosophical perspectives that challenge and extend beyond these boundaries. Materials needed: PowerPoint slides, excerpts from philosophical texts, and a guided meditation or reflective exercise. Detailed script. 1. Introduction to the limits of wisdom. Today, we venture beyond the familiar territories of knowledge and wisdom to explore their limits. Conventional wisdom, as invaluable as it is for practical decision-making, has boundaries. Let's discuss what lies beyond. 2. Understanding conventional wisdom. Conventional wisdom represents widely accepted beliefs or norms. It's practical, often based on common experience or societal consensus. However, it may not always lead to deep understanding or innovative thinking. 3. Philosophical challenges to conventional wisdom. Philosophers throughout history have questioned and pushed the limits of conventional wisdom. Socrates' famous assertion, "I know that I know nothing," invites us to embrace the unknown and question accepted truths. 4. Beyond conformity to critical thinking. True wisdom often involves stepping beyond conformity to question deeply held beliefs. This critical thinking can lead to breakthroughs in understanding and innovation. 5. Reflective exercise, questioning our assumptions. Let's engage in a reflective exercise. Think of a belief you hold as unquestionably true. Now, challenge this belief. Consider alternative perspectives or contradictions. Share your thoughts with a partner. 6. Conclusion. By recognizing the limits of conventional wisdom, we open ourselves to a broader spectrum of understanding. Philosophical inquiry is a powerful tool for transcending these boundaries, pushing us toward deeper insights. Homework assignment. Choose a philosophical quote or idea that challenges conventional wisdom. Write a reflective essay on how this idea impacts your understanding of wisdom and its limits. Lesson 10: Spiritual and Transcendental Wisdom. Objective: examine spiritual and transcendental perspectives on wisdom, exploring how these viewpoints can offer a deeper, more interconnected understanding of reality. Materials needed: PowerPoint slides, quotes or teachings from various spiritual traditions, and materials for a creative expression activity, for example, art supplies, writing tools. Detailed script. 1. Introduction to spiritual wisdom. As we delve further beyond conventional wisdom, we enter the realm of spiritual and transcendental wisdom. These perspectives offer profound insights into the interconnectedness of life and the universe. 2. The essence of spiritual wisdom. Spiritual wisdom transcends intellectual understanding, emphasizing inner knowledge and the interconnectedness of all things. It's about finding harmony and understanding beyond the material world. 3. Examples from spiritual traditions. Various spiritual traditions offer insights into transcendental wisdom. For example, the concept of Dharma in Buddhism, the Tao in Taoism, and Sophia in Gnostic Christianity. Each provides a unique lens on understanding beyond the physical. 4. Transcendental wisdom and understanding. Transcendental wisdom involves transcending the self to achieve a deeper connection with the universe. It's about understanding our place in a much larger context and the pursuit of ultimate truths. 5. Creative expression activity. Let's express our reflections on spiritual or transcendental wisdom creatively. You can write a poem, draw, or create a short narrative. Focus on the theme of interconnectedness or a transcendental insight you've felt or imagined. 6. Conclusion. Exploring spiritual and transcendental wisdom encourages us to consider deeper questions about existence, purpose, and interconnectedness. These perspectives challenge us to look beyond the surface and to seek a more profound understanding of our world and ourselves. Homework assignment. Reflect on a personal experience where you felt a deep sense of connection or understanding that went beyond conventional wisdom. Describe this experience and your insights in an essay or creative piece. For Module 6, The Science of Everything, we'll develop 2 lessons that bridge the gap between knowledge as previously discussed and the structured inquiry known as science. These lessons will delve into how the scientific method underpins the pursuit of knowledge and explore the transformative impact of scientific revolutions and potential future directions of scientific discovery. Lesson 11: Science as a form of knowledge and the scientific method. Objective: introduce science as a systematic approach to acquiring knowledge, emphasizing the role of the scientific method in this process. Materials needed: PowerPoint slides, examples of scientific discoveries that changed our understanding, and an experiment or demonstration to illustrate the scientific method in action. Detailed script. 1. Introduction to science as knowledge. Today, we explore science not just as a body of facts but as a dynamic form of knowledge. Science, at its core, is a methodical approach to discovering truths about the world around us. 2. The nature of scientific knowledge. Scientific knowledge is characterized by its basis in empirical evidence, its testability, and its ability to evolve over time. Unlike static knowledge, scientific understanding continually adapts and grows with new discoveries. 3. The scientific method explained. The scientific method is a systematic way of learning about the world. It involves making observations, forming hypotheses, conducting experiments, analyzing results, and drawing conclusions. This process is the backbone of scientific inquiry. 4. Demonstrating the scientific method. Let's conduct a simple experiment to demonstrate the scientific method in action. Conduct an experiment, such as testing the solubility of various substances in water, illustrating each step of the scientific method. 5. The significance of the scientific method. This method not only allows scientists to uncover new facts but also to challenge and refine existing knowledge. It's a tool for building a more accurate understanding of the universe. 6. Conclusion. Science, as a form of knowledge, is ever evolving. Its strength lies in the scientific method, a rigorous process that enables us to explore, discover, and understand the complexities of the world. Homework assignment. Choose a scientific discovery that interests you. Research and write about how the scientific method was used to achieve this discovery. Include the hypothesis, experiment, and how the findings impacted our understanding of the topic. Lesson 12: Major Scientific Revolutions and the Future of Science. Objective: explore key scientific revolutions that have shaped our understanding of the world and speculate on the future directions of scientific inquiry. Materials needed: PowerPoint slides, timelines or infographics of scientific revolutions, and a discussion or debate set up on future scientific challenges. Detailed script. 1. The impact of scientific revolutions. Today, we journey through the transformative power of scientific revolutions. These pivotal moments have not only advanced our understanding but have reshaped how we view the world. 2. Highlights of scientific revolutions. From the Copernican revolution, which redefined our place in the cosmos, to the quantum revolution, which challenged our understanding of reality. Each scientific revolution has expanded the boundaries of knowledge. 3. Characteristics of scientific revolutions. Scientific revolutions share certain traits. They challenge existing paradigms, are often met with resistance, and ultimately lead to a new framework of understanding. They are catalysts for change, driving forward the pursuit of knowledge. 4. The future of science. As we look to the future, science faces both opportunities and challenges. Areas like artificial intelligence, genetic engineering, and climate science promise to further revolutionize our understanding but also pose ethical and practical questions. 5. Debate, the next scientific revolution. In groups, debate what you believe will be the next scientific revolution. Consider the potential impacts on society, the challenges we might face, and the ethical considerations involved. 6. Conclusion. The journey of science is one of continual discovery and revaluation. As we stand on the brink of new scientific frontiers, it's crucial to consider not only the potential for knowledge but also the responsibility that comes with it. Homework assignment. Imagine you are a scientist 100 years in the future. Write a letter back to the present day, describing a scientific revolution that has occurred. Detail its impacts on society, the challenges overcome, and the ethical considerations addressed. For Module 7, Synthesis and Beyond, we will create 2 lessons designed to culminate and extend the explorations from the previous modules, guiding students through a process of integrating their learnings into a coherent understanding that reaches beyond current limitations. Lesson 13, Integrating Knowledge Dimensions. Objective: to synthesize the concepts of data, information, knowledge, and wisdom explored in previous modules, highlighting their interconnectivity and the process of transcending to higher forms of understanding. Materials needed: PowerPoint slides, diagrams illustrating the relationships between data, information, knowledge, and wisdom, and examples of innovative thinkers who have pushed the boundaries of understanding. Detailed script. 1. Introduction to integration. As we approach the culmination of our journey, we stand at the intersection of data, information, knowledge, and wisdom. Today, we aim to weave these threads into a cohesive tapestry of understanding. 2. The continuum from data to wisdom. Recall the progression from raw data, to structured information, to insightful knowledge, and finally, to discerning wisdom. Each step is crucial, building upon the last to achieve greater depth of understanding. 3. Case studies of integration. Consider historical figures like Leonardo da Vinci or Marie Curie, whose contributions transcended disciplinary boundaries, integrating knowledge and wisdom to pioneer new frontiers of understanding. 4. The role of imagination and creativity. Imagination and creativity are the engines of transcendence. They propel us beyond the known, enabling the leap from knowledge to wisdom, and from wisdom to realms beyond current understanding. 5. Group discussion, limits of understanding. In groups, discuss a current limitation in understanding within any field. Propose how integrating data, information, knowledge, and wisdom could help transcend this limit. Share your ideas with the class. 6. Conclusion. The journey from data to wisdom is not linear but cyclical, with each phase of understanding informing and enriching the others. As we integrate these dimensions, we prepare to push beyond into new realms of understanding. Homework assignment. Select a topic that interests you deeply. Create a comprehensive overview that demonstrates the integration of data, information, knowledge, and wisdom. How does this integration provide a pathway to transcending current understanding? Lesson 14, Envisioning the Ultimate Quest for Understanding. Objective: encourage students to envision the future of knowledge, wisdom, and science, considering the ultimate quest for understanding and the role of human creativity and imagination in reaching beyond current capabilities. Materials needed: inspirational materials, videos, articles, creative tools for a project-based activity, and guidelines for the final project. Detailed script. 1. Beyond current understanding. In our final lesson, we turn our gaze forward, envisioning the future of understanding. What lies beyond the highest wisdom and the farthest reaches of science? 2. The role of imagination in science and wisdom. Imagination is not just the domain of artists and writers. It is equally vital in science and philosophy, where it breaks down barriers and opens new territories of understanding. 3. Pioneers of the future. Consider visionaries like Elon Musk or Ada Lovelace, whose imaginative leaps have, or had the potential to, redefine our world. What common threads can we identify in their approaches? 4. Final project introduction. Your final project will be to conceptualize a novel idea, theory, or model that represents a form of understanding that transcends current human capabilities. Think boldly and creatively. 5. Preparing for the final project. Begin by identifying a field or question that captivates you. What limitations exist in our current understanding? How might you envision breaking through these boundaries? 6. Conclusion. As we conclude our course, remember that the quest for understanding is unending. Each answer leads to new questions, and each summit reveals new horizons to explore. Your final projects are your first step into this boundless journey. Homework assignment. Draft an outline for your final project. Include the topic, the current limitations in understanding, and a preliminary vision for transcending these limitations. Be ready to discuss your ideas in the next class.